Welcome to session 4 under unit 1, other classifications of aromatic compounds. So at the end of the session, you should be able to classify cyclic conjugated system as either anti-aromatic or non-aromatic. Give example of anti-aromatic compounds and identify other cyclic molecules and ions which do not contain benzene ring as aromatic compounds. So we will first look at anti-aromatic compounds. Now, in the previous session, we talked about aromatic compounds and we look at the criteria we use to identify a compound as aromatic or not aromatic. Now, there's another criteria we can use to identify a compound as anti-aromatic. That is, if the compound is not aromatic, then it could either be anti-aromatic or non-aromatic. But first of all, we will take anti-aromatic first. Now, for a compound to be regarded as anti-aromatic, it means it's cyclic, just as aromatics. It's planar, just like aromatics, and then of course being conjugated, the pi electron system as well. However, if it fails to obey the Haeckel's rule of 4n plus 2 pi electron system, and rather obeys the 4n pi electron system, then that compound is regarded as anti-aromatic. So although the compound will be cyclic, planar, and conjugated, alright, if it fails the Haeckel's rule of 4n plus 2, but then obeys the 4n pi electron system, then we'll call that compound as anti-aromatic compound. The typical example is our cyclobutadiene. So when we were talking about cyclobutadiene, we said cyclobutadiene is not an aromatic compound, although it's planar, cyclic, and conjugated. It's not an aromatic compound because it does not obey the 4n plus 2 pi electron system, but rather obeys the 4n pi electron system. So if you use the 4n pi electron system for this, it means 4n will be equal to 4, and your n will be equal to 1. So if your n equals 1, then cyclobutadiene will obey the 4n pi electron system. And the same goes for all these compounds. This has 2 pi electrons, making 4 pi electrons here. This has 2 pi electrons here, and 2 different lone pairs of electrons. But whenever we talk about resonance and delocalization, we want to use just the pair of electrons that are delocalized, and not all 4 of these are going to be involved in resonance. Only 2, just 1 pair will be involved in resonance. So here there are not 6 pi electrons, but there are only 4 pi electrons involved in resonance. Here also 2, and then 2 here, making 4. Here there's 2, 4, 6, 8 pi electrons. And if you look at 8 pi electrons, that means 4n equals 8 will give us n being 2. So it means all these structures here are anti-aromatic compounds. They are planar, alright, they are conjugated, and they are cyclic, but they all obey the 4n pi electron system, and not the 4n plus 2 pi electron system of Haeckel. The next group will be the non-aromatic compounds. Now, if a compound obeys the Haeckel's rule, it's planar, conjugated, and cyclic, then we say that the compound is aromatic. If the compound obeys the first 3 rules but fails at the Haeckel's rule, then we say the compound is anti-aromatic. However, if a compound does not obey any of the first 3, that's if the compound is either non-cyclic, non-planar, or do not have a complete conjugated system, then that compound becomes a non-aromatic compound. So a typical example is if you look at the structure D here. Now this structure is not even planar in the first place. So automatically it fails to become an aromatic compound. It's not aromatic, it's not anti-aromatic, it's rather non-aromatic. Now the next one is, if you look at the structure B here, structure B also fails conjugation. There's no conjugation after this carbon double bond. There's a single bond, there's another single bond, so it's failing the conjugation here, and it becomes non-aromatic. Now 10-aniline is also, basically when you say 10-aniline, it means it's an aniline comprising 10 carbons. It's aniline, then aniline is conjugated, alright. But the actual structure from molecular orbital theory suggests that the structure is not planar. So one of its hydrogen points up, one points down. So the compound is not planar. So if the compound is not planar, it means it's a non-aromatic compound. Then we also have the benzenoid aromatic compounds. These are compounds which contain only benzene rings in the whole structure. Typical example is naphthalene, anthracene, and phenanthrene. So we have aromatic, we have anti-aromatic, we have non-aromatic, and then benzenoid aromatic compounds. Then also we have non-benzenoid aromatic compounds. So these are compounds that do not necessarily contain the benzene structure, however, are obeying the Haeckel's rule, and therefore we refer to them as non-benzenoid aromatic compound. So non-benzenoid aromatic compound do not have the benzene ring in them at all. They have other structures. They are composed of different structures, but they obey the Haeckel. So if you compare these two structures, 1,3-cyclopentadiene. If you look at this structure is non-aromatic because it's not planar. The hydrogens are pointing at different directions. They are not in the same plane. So this compound is non-aromatic. However, its anion, cyclopentadiene anion, is aromatic because there are two lone pairs that add up to the 4 pi electrons present in the ring. So in the first structure we have just 4 pi electrons, but the second structure has 6 pi electrons involved in conjugation and resonance, and therefore this anion is regarded as an aromatic compound. However, in its neutral state, it is regarded as a non-aromatic compound. And this is a typical example of non-benzenoid aromatic compound. These are other examples of non-benzenoid aromatic compounds. So we have the tropolone, tropylium cation, we have azulene, and then the cyclopropynium cation, or the cyclopropynium cation. So all these structures are aromatic. They are cyclic, they are planar, they are conjugated, and they obey the Haeckel's rule. But you can see that none of them has the benzene structure. So they are non-benzenoid aromatic compounds. They are aromatic compounds, alright, but they do not have the benzene structure. And these are also non-benzenoid aromatic compounds. All these being anti-aromatic because the N is either not an integer or they do not obey the 4n plus 2 pi electron system. So if the compound does not obey the 4n plus 2 pi electron system, it is regarded as anti-aromatic, even though it might be planar, conjugated, and cyclic. Next is the annulenes, and they are completely conjugated monocyclic polyenes or hydrocarbons with this chemical formula. And just as we've been talking about, if the compound obeys the Haeckel's rule, then it is regarded as aromatic, but if it fails the Haeckel's rule, it is regarded as anti-aromatic. So 12-annuline obeys the 4n plus 2 pi electron system where n is equals to 3, but 14-annuline obeys the 4n plus 2 pi electron system where n equals 3. So 12-annuline is anti-aromatic, whereas 14-annuline is aromatic.